Welcome back. I want to revisit a few terms that we've seen before and that we should be familiar with. That is, in JavaScript, functions are first-class citizens, which means we can have higher-order functions and we can also have closures. Now, let's start off with higher-order functions and review what they are. Higher-order functions, both in mathematics as well as computer science, simply means it's a function that does one of two things. It either takes one or more functions as arguments, or returns a function as a result, often called a callback. So we can write a fairly simple higher-order function, such as const hof, and this higher-order function will be a function that returns another function. This is a higher order function because when I do hof for a higher order function, and I don't need a return here because with an arrow function, if it's on the same line, the return is implied. You see that I get a function. So it's a function that returns a function. So if I call this again, there you go, I get 5. So that's a higher order function. Another function could be a function that returns as or receives as a parameter a function. So here I can just call function 5. So that if I do hof and in here give it a function, like function a is a function that, let's say, returns 5. Or in our case, it'll return x, which is our parameter. If we do this and run, return, make sure I spell that right. Let's try that again. There you go. We have 5. This is a function. The parameter of hof takes a function. So that's a higher order function as well. And the interesting thing about higher order functions and the fact that functions are first-class citizens in JavaScript means we can do closures, right? And we had a whole section on closures, so you should be familiar with it by now. Let's just review. Like objects, closures in JavaScript are a mechanism for containing some sort of state. And in JavaScript, we create a closure whenever a function accesses a variable defined outside of the immediate function scope. That is the scope of the parent. And it's fairly easy to create a closure, right? We simply define a function inside another function and expose the inner function either by returning it or passing it to another function so that we can use that variable. Let's have a look at an example. I can say variable, or let's do const, has a closure function. And this closure function will have a variable, let's call it let count, which for now will equal 0. And it's going to return another function that will say increment. And increment will simply increase the count. Or we can just do plus plus. So that when we run the closure function and I click run, I get the increment function. And if I run this again, or if I assign it to a variable and call it const increment function, I can now call the increment function whenever I want. Let's see. I get undefined because it's not returning anything from the actual increment. So let's just return count to see what we get. We get 1. If I call this again, there you go. We get 2. And then once again, for good measure, we get 3. Now, even though the initial closure function was called and we're done with that, Because of closure, this increment function remembers the variable used by or declared in the outer scope. So the variable used by the inner function will be available to it, even after the outer function has finished running. And you might notice two things if you have been following along with our functional programming concept. One is that we're modifying state outside of our function, aren't we? This increment function is touching state or data that belongs to another function, the closure function. And when it comes to functional programming, it doesn't mean we can't use closures. We can definitely still use closures, and they're very powerful. But we have to be careful that closures only make a function impure if we modified the closed over variable. If instead our increment is just a get counter, for example, that returns the counter, and let's say the counter is at 55, and we'll change the name of this to get counter, and I run this, I get 55. We're using closures here, and although we're not modifying the state like we had before, we still have access to data outside of ourselves. But as long as we don't modify it and mutate the data, we're still following the functional programming paradigm. Something that is nice with this is that we just created private variables. We're able to use closures to create data privacy, which is very, very cool. Because now, as a user, I can't really modify the count. Maybe this is a super important don't touch variable. Because we're using closures, we're able to still have access to that variable, but make sure that others don't modify it, which is a very, very nifty tool. And closures get used a lot in functional programming for this specific reason. We just have to be careful not to modify the state. So now that we've just gone over higher order functions and closures, we can keep going with our functional programming terminology. I'll see you in the next one.